Okay. Well, because it's good.
Alright, radio silence.
So, let's start with sine, the integral of sine theta cos to the fifth theta d theta. So, if you're going to let u be something, what would u be?
Cos.
So u would be cos theta. Then what's du? Negative sine theta d theta. And we have a sine theta d theta, so we're good, right? We can do a U-substitution on this. And so what we might want to say is, well, that sine theta d theta, I'm going to replace that with negative du. Right? So there's my sine theta d theta. There it is up there. So when I go to write this with U-substitution, be the integral of u to the fifth. So that's cos to the fifth, right? Cos to the fifth theta times negative du. And we'll just throw the negative out front. And we got u to the fifth du. And what's the integral of u to the fifth? One-sixth u to the sixth. And on the end, we will tack on plus c. And then to finish it off, because it's never about you. Negative 1/6 cos to the sixth theta plus c. Okay, easy peasy, usual U-substitution, right? No problem. All right, now we want to skip to the last part of example 2, which is the cos cubed theta. This one. No, not that one. That's cos cubed sine to the fourth. This one. Now, this is a definite integral. Okay. But let's just say we were doing the indefinite, just the integral. Let's just go over here and decide. I want to do the integral of cos cubed theta d theta. So, what's u going to be?
Cos theta.
Okay, so if u equals cos theta, then what's du? That's going to mean we just did this one, right? Basically, right? That's negative sine theta d theta. Here's the problem: we don't have a sine theta in the original, right? So there's no sine theta. In the original. So we can't do U-substitution like that. So similarly, if that was sine cubed theta, then we say, okay, u equals sine theta. Then we need a cos theta, right? Because the derivative of sine is cos. And we don't have that. So somehow we have to get that. We need to be able to get a sine theta in there or something. So here's what we do. We say it's going to be the integral of cos squared theta times cos theta d theta. Now, what's cos squared times cos? Cos cubed, okay? So we're rewriting cos cubed theta as cos squared theta d theta. And now, what can we say? Well, we need a sign though, right? Show me a sign. So what's cos squared, right? 1 minus sine squared theta times cos theta d theta. So now, if I let u be sine theta, so let u equal sine theta, then what's du? So du is cos theta d theta, right? So now, we're okay. We let u, we can do a u substitution on this. We've got the cos theta d theta, right? So that's just going to be replaced by du. This is just going to be the integral of 1 minus u squared. So we get the integral of 1 minus u squared du. And we could do that. What's the integral of u of 1 minus u squared? It's going to be u minus 1/3 u cubed plus c. So if we were doing the indefinite integral, right, because we're going to do the problem, the actual problem that exists there, then we would say, okay, well, I'm going to replace u with sine theta. So it's sine theta minus 1/3 sine cubed theta plus c.
Yeah, but why'd you start off doing like right margin? I feel marginalized.
Well, if you move to Trump's America, you should get used to it.
Oh, this guy.
So I started here because I'm doing the indefinite integral, right? Just so, do an example of, hey, what if we have cos cubed, right? So we did one, we had cos to the 5th, but it had sine theta. We said, all right, let u be cos theta, and all right, we've got our sine theta, d theta, it's all good, we could do a U-substitution back there. Here, well, the only thing we've got with cosine, right? But now I got a problem. If that was sine cubed, I'd let u be sine, I'd need cos. I don't have this. Right? I can't replace that. But we have a technique that we can apply, right? So what we should do is say, hey, I'm going to write this. It's an odd power. I'm going to write it as an even power times cos theta. If that were cos to the 5th, I would just write this as cos squared squared and write that as a squared, right? Because we could do that or undo that, right? If we were doing cross those off, because that's not what it is. Now, let's do the actual definite integral. So the definite integral, what we're going to do is, we're going to do this part here. We're not going to do this part here. Because what we're going to do is just figure out for u. So now that we know how to do it, let's just say, all right, that's why it's marginalized, right? Because that's an indefinite. But now we know what we're doing. How do we do this problem, which is a definite integral? So we would start off here by saying, okay, so u is equal to, well, first we rewrite this. So it's the definite integral pi over 3 to pi of cos squared theta cos theta d theta. We would then rewrite the cos squared as 1 minus sine squared. So this time still definite integral 1 minus sine squared theta cos theta d theta. Okay, now we can let u equal sine theta. So in a sense, we're sort of pretending this doesn't really exist, right? Like, you know, but it's there. We can look at it. And that means that du is cos theta d theta. Okay, so we're good now, right? Cos theta d theta, replace the sine with the u, it's all good. But we're doing a definite integral. So we say, okay, when theta is equal to pi over 3, so when theta is equal to pi over 3, then u is equal to sine pi over 3, which is, what's the sine of pi over 3? Root 3 over 2. And when theta is equal to pi, u is equal to sine pi, and what's the sine of pi? 0. Okay, so we're not going to go back to x once we've done this, right? So what we're now going to say is, all right, I want.
Would this Flanagan call the office? Immediately, Ms. Flanagan call the office? Thank you.
The definite integral, the pi over 3, when theta is pi over 3, u is root 3 over 2. To pi, when theta is pi, then sine theta is 0. Okay, of, okay, and we've got now 1 minus u squared du. All right, so we do the integral, which we've done, which is u. So we've got u minus 1/3 u cubed. We don't need a plus c. It's a definite integral, right? We're evaluating it. And we want to do that from a lower limit of root 3 over 2 to an upper limit of 0, which will be equal to, so 0 minus 1/3 0 cubed minus root 3 over 2 minus 1/3 root 3 over 2 quantity cubed. Okay, so we just have to work this out. First batch is 0, right? So it's just going to be 0.
So you'll put the C in if it's a,
If it's a definite integral, if you did, you'd just be subtracting it off, right? So, yeah, we don't bother with it. Yeah, when it's a definite integral, we don't because we're going to be evaluating it.
we'll only lose marks, right?
No.
Okay.
You actually more likely lose marks for putting it in than not, but it's not going to make that difference.
When you're looking at like the limits, like the
Yeah.
root 3 to 2 is 0, normally isn't it?
Yeah, it's still upper minus lower, so upper in this case happens to be lower than, but that's okay. What this means is it's going to end up being negative, right? Which is what that difference between the areas is.
You
So
have to make sure to like keep the order.
you make sure that if you're lower, it's pi over 3, for you it's replaced by root 3 over 2. Yeah, that's what's going to turn this negative, right? So this would be negative-ish, maybe. I don't know what's going to happen with this, but this is 0. So we got 0 minus, and then, so let's work this out. What do we got here? So root 3 over 2 minus 1/3. So what's root 3 over 2 quantity cubed? How about, well, it's root 27, which is 3 root 3. It's like root 9. Like when I square it, I'll get a 3. So here, look, I got a 3, and then I got a root 3 here, and then I got an 8 on the bottom. Okay, so these guys cancel. And so I want to make an 8 on the bottom. So this will be 4 root 3 minus root 3 all over 8. Right? So I got to put that over 8, so it'll be 4 root 3 over 8 minus, these guys cancel, I got 1 root 3 over 8, which is negative 3 root 3 over 8. Okay, so that's what that one's going to be about. So that's the definite integral. Now if you wanted to, you could take this, the sine theta minus 1/3 sine cubed theta, without the c, and evaluate it from lower limit of pi over 3 to an upper limit of pi, right? And you should get the same answer. Okay, you get the same answer. Yep. Nope.
Because it's cubed.
Yeah, but this is 3 root 3, so these 3's canceled. So it's 24 until I cancel it. That's 8. Okay, now must follow roadmap. What is example 3? Oh, example 3. So right below where we started on example 1, we're now moving there.
Wait, so why did we do this one first?
Because I wanted you to see the problem is this is just this. Yeah, this is just a straight U-substitution. There's no problem here. Right? Then I wanted you to see, oh, but there's a problem if we have like sine cubed, cos to the 5th, 7th, whatever. Okay, now we're coming back to this. So this has sine cubed and cos squared. So here's the deal. If we let u be sine theta, we need a cos theta. We don't have a cos theta. We got a cos squared theta. If we let u be cos theta, we need a sine theta. So the thing is, what we want to do is, I want to get a sine theta by itself. Now I can do that by splitting the sine cubed theta up into sine theta times sine squared theta times cos squared theta d theta. Now the sine squared is going to become what? What's sine squared equal to? 1 minus cos squared. So I got sine theta, got 1 minus cos squared theta, and a cos squared theta, and a d theta. So at this point, Well, we can stick this cos into there. So let's write this. We're going to get, expanding this, we'll get a cos squared theta minus cos to the fourth theta. Okay, and that will be times sine theta d theta. All right, so I just put the cos squared theta into the brackets with the 1 and the cos squared theta.
Whoa.
Okay, now look, I've got a sine theta d theta. Everything else is cosine, right? Which is good because now I let u equal cos theta. Then du becomes sine theta d theta. Then this just becomes du, and this becomes u squared minus u to the fourth. It doesn't get much easier doing integrals of those, right? So at this point we say let u equal cos theta. And du is equal to, what's the derivative of cos? Minus sine theta. As a lot of people lost because it's net minus sine theta, not sine theta. So minus sine theta d theta, which means negative du is sine theta d theta. Okay, so this, it's going to be, is this, which will be replaced by this, right? Be replaced by a negative du. So we now have the integral, okay, u is cos theta, so we've got u squared minus u to the fourth times negative du. Okay, so sine theta is replaced by negative du. Negative, we'll just kick that out front. So negative, got u squared minus u to the fourth du. Don't leave the brackets off. Make sure there's brackets. It's the u squared minus u to the fourth, which is negative. Okay, the integral of u squared. 1/3 u cubed minus 1/5 u to the fifth plus c, which is equal to negative 1/3 u cubed plus 1/5 u to the fifth plus c. Yeah, I know, now the c is a negative, but it's still just a constant. Okay, if you want to write a c1 or c2, there'd be my guess. Which is ultimately, now back to u, which is cos theta, right? So the finishing touch, negative 1/3 cos cubed theta plus 1/5 cos to the fifth theta plus c. Okay? And if you do these derivatives, if you don't believe this for some reason, then just do the derivative of this and see, do I end up with that? Okay? And if you don't, then you've got to keep working it until you do. Okay, so the idea here is, in this particular problem, we need a sine theta or cos theta by itself. Okay, so we need a sine theta or cos theta by itself. If we have that, we're good, right? That's why we did the one up above first. See, look, hey, we got a sine theta by itself. Okay, that's good. So then I let u be cos theta, and I get u, right? Then I went to the cos cubed, and we said we don't have one by itself. But wait, we can, manipulate this, right, by taking the odd power, splitting it up. So we've got the single thing. Here we did it just higher powers. Okay, put your trust in a higher power. Now, example 4. Okay, that was odd. This is even. What happens if you just have sine squared theta d theta? Okay, the problem is that we can't split out a sine theta, right? Because then you go, well, then u is sine theta, and then du is cos. No, I don't have a cos theta. All right, so I got problems. So now we go back to the beginning.
Whoa, we're doing.
Now we go back here. Integration. It just made more sense to introduce this now because. So what are we going to do with the sine squared theta? Well, we have two identities that are useful. Sine squared theta is 1/2 of 1 minus cos 2 theta. Okay. Now it's asking you to prove that, or I suppose verify that. I don't know. So we'll just work the right hand side and see if we can come up with a sine squared theta. Okay. So the right side is equal to 1/2 of 1 minus the cos of 2 theta. But what's cos 2 theta? So it's any one of these guys. Which one is most likely to lead us to a sine squared theta? And probably the one that just has a sine squared, right? We don't want another cos squared. I do that, I got a cos squared, and then no. So 1 minus. So we're going to replace cos 2x, or cos 2 theta, with 1 minus 2 sine squared theta. So we have 1/2 times 1 minus bracket 1 minus 2 sine squared theta. So it's a half, and we've got 1 minus 1 plus 2 sine squared theta. What's 1 minus 1? 0. So we just got a half times 2 sine squared theta, which is sine squared theta. Okay, so you see sine squared theta, you can replace it with a half of 1 minus cos 2 theta. Okay, now to get from here, 1 minus 2 sine squared x equals cos 2x, right? You're going to have to do this. Negative 2 sine squared x is equal to cos 2x minus 1, and then divide by negative a half, getting sine squared x is, so that's going to be negative times that would be a half, and this would be minus 1/2 cos 2x, or just the half times 1 minus cos 2x. Okay, so you may have to generate that yourself from the identity that you're given, right? Because it's not another formula. There's no formula here that says sine squared is equal to a half of 1 minus cos 2
Well,
theta.
that's on the formula sheet.
Yeah, this is on your formula sheet. So what you have to do is say, I know there's a way of getting sine squared in terms of like cos 2 theta or cos 2x. Okay, I can do that from here. I can just set them equal to each other and then solve it for sine squared. Okay, so I could do that. Now, what if we had cos squared? Well, we want cos squared theta to be a half of 1 plus cos 2 theta. So which of these three guys are we using? So the middle one, right? So we're gonna prove this identity. Yeah, so the right side is equal to 1/2 of 1 plus cos 2 theta, which is 1/2 of 1 plus 2 cos squared theta minus 1, which is 1/2 of 2 cos squared theta, which is cos squared theta. Okay, and again, the idea is I have cos squared, and I want to express, they don't know why. It's like, why are we doing this? When we do the example that we're doing, then you say, oh, that's why. Okay, so yeah, why are we doing this? Because we want to find the integral of sine squared, right? And we can't. Okay, not without doing something.
Let's see, Robert.
One other possibility, which is that you might sometimes use 1/2 of sine 2x is equal to sine x cos x. Okay, and all that's doing is just taking a half of both sides. That doesn't require much in the way of proof or anything, right? Just if you see a sine x cos x, you could replace it with 1/2 of sine 2x. Okay, may possibly come in handy. Okay, where? All right, here we are. So now we want to do sine squared theta d theta. All right, this is example 4. Okay, so backing up one little bit. So with an odd power, we want to separate it out into a power of 1 and then an even power, right? So if it was sine to the 5th, I'd separate it to sine theta and sine to the 4th theta. Sine to the 4th theta is just sine squared squared. So I could just do 1 minus cos squared and then square that, right? So, but this guy, what do we want to do? Well, we're going to replace the sine squared with 1/2 of 1 minus cos 2 theta d theta, which is the integral of 1/2 minus 1/2 cos 2 theta. So just distributing the half. Okay, well, what's the integral of a half? It's just 1/2 theta, right? What's the integral of minus a half cos 2 theta? Okay, so let's do, well, the integral of cos 2 theta is sine 2 theta, right? So what's the derivative of sine 2 theta? Well, that's 2 times cos 2 theta, right? Which means we're going to have to, there's going to be a 2 come out, so it's going to have to be 1/4. Okay, and it needs a minus sign because the derivative of sine is positive cos. Okay, so now if you take the derivative of minus 1/4 sine 2 theta, it's 2 times the quarter is the half, 2 times cos 2 theta, and that's what we want.
So we able to use U in this case?
No U. Not all about you. It's not always all about you. So this is if we have an even power.
Trumps U.
Now, what if we have 2 even powers? So the next example is sine squared theta, cos squared theta. What we're going to do with that is, again, right, all I have is an even power. If that was sine cubed, I write it as sine theta, sine squared theta, replace the sine squared with 1 minus cos squared, etc., and away we go. Here, we have 2 things which are squared. So we go, the integral of, so sine squared gets replaced by 1/2 of 1 minus cos 2 theta. That's sine squared. And cos squared gets replaced by 1/2 of 1 plus cos 2 theta. D theta. Okay, so we got 1/2 times 1/2 is 1/4. So we can pull that quarter, because it's just a constant. We pull the quarter out, and I get 1 minus cos 2 theta times 1 plus cos 2 theta. Let's bracket d theta. Okay, so now we just get to multiply that out, right? So we get what? So 1/4 integral, so we got 1 plus 2 minus is gone, right? Minus cos squared 2 theta. D theta. But what's cos squared of x? So over here. But, well, this is just going to explain where the next line comes from, right? If you don't have this explanation, I'll write the next line for you here. So next line is this. 1/4, 1 minus 1/2 of 1 plus cos 4 theta. D theta. Right? So this is true. Yeah, wait, what? What? Where'd that come from? Okay, so remember, cos squared x is equal to 1/2 of 1 plus cos 2x. Okay, now for us, what's the x? It's a 2 theta. So everywhere we see an x, we're just going to write 2 theta. So cos squared 2 theta is equal to 1/2 of 1 plus cos of 2 times 2 theta, which is 1/2 of 1 plus cos 4 theta. So that's where the 1/2 of 1 plus cos 4 theta came from, right? And the idea was just, hey, look, we've got a cos squared of something again. Fine, let's just replace it. Now you notice we're only in one variable here, right? We're only in cos theta, so we're just going to clean up what's in here, and then we'll do the integral. So 1/4, and what do we got in here? We got 1 minus 1/2 minus 1/2 cos 4 theta. D theta. Okay, so 1 minus 1/2 is 1/2. So it's 1/2 minus 1/2 cos 4 theta. D theta. No u required here, right? We just do the antiderivative of that relatively easily. So 1/4. Okay, what's the antiderivative of 1/2? 1/2 theta. 1/2 theta. Okay, now the cos 4 theta, that's going to be a sine 4 theta, right? And sine 4 theta, when we do its derivative, right, or antiderivative. So if we do the antiderivative, here, let's do it in kind of 2 steps. Okay, Okay, so the integral of cos 4 theta is 1/4 sine 4 theta. Okay, and then we'll just stick the half in there, and we'll be done. Well, now we put the quarter in. So it's 1/4 times a half, which is 1/8 theta. Oh, I suppose we should toss in a plus c. And here we've got a half times 1/4, which is 1/8, times the quarter from out here, so it'll be 1/32. So minus 1/32 sine 4 theta. Plus c. Same c, different c, whatever you like. It's 1/4 of the original c, but it's the interesting thing, which I'm not going to do, would be do the derivative of this and see if it really does come out as sine squared. No, I'm not. I was just saying you could just try it yourself, right? Like you could try one of these and say, okay, does this stuff really work?
Yeah.
You know, like,
We go up to that size. Yeah.
okay. So this. So from this line, this is why we got down to this line, right? Because if I just wrote this and wrote this, then you'd just be, yeah, like what magic did you do here, right? Like somehow that appeared. Okay, and I have no idea what that did. All right. Ooh, example 6 actually the next example. Yeah, there's a couple.
I was just wondering, given the 1/2, 1 minus cos 2 theta, and 1 plus alpha,
Yep.
which one do you use?
You can derive them from the formulas that are on your formula sheet. So, the question was, do you have to know these 1/2, 1 plus cos 2 theta, and 1/2, 1 minus cos 2 theta? And the answer is, you have to know how to get it. You may not have to know it. So if you see an integral and it's got just sine squared or just cos squared, then you got to say, oh, I got to do the whole cos 2 theta thing. And then you just go back to this, which is your formula sheet, and say, I'm using these to solve for either cos squared or sine squared. Okay? So we don't give them to you. But you don't have to memorize them, because you'll probably do it wrong. But you just have to be able to get it from that.
Oh,
Okay? So, but if you don't have an integral of a sine squared, then you don't need that. All right. All right, this is the next one? This is the next one. Okay, so, definite integral. We've got an odd power of cos. This is good, right? So, if this was cos to the 4th, sine to the 4th, we would do exactly what we did on the other one, only everything we had there would be squared. Right? Like when we replace sine squared, it would be sine squared squared. Okay. Now, we're not doing this here. We're saying, I've got an integral, got an odd power. So with an odd power, then I do this. I write this as the integral from 0 to pi over 2 of cos theta times cos squared theta times sine to the 4th theta d theta. Right? And I'm probably happier if I see brackets around the whole thing, but whatever. Which is equal to the integral from 0 to pi over 2 of, so I'm going to write cos squared as 1 minus sine squared theta times sine to the 4th theta times cos theta d theta, right? Now I'm moving that down there because we know we're going to let u equal sine squared, right? We're just going to get this as, actually let's go one more line. So integral 0 to pi over 2. So distribute the sine squared. We've got sine, or the sine to the 4th. We've got sine to the 4th theta minus sine to the 6th theta cos theta d theta. So at this point, we let u equal sine. Right? We got u to the 4th, u to the 6th. Like they don't get much easier than that as far as doing integrals, right? And we've got the cos theta d theta is just going to be the du. We don't even have to worry about a negative this time.
yeah.
Okay? So, let's go over here. Let u equal sine theta. Then du is cos theta d theta. And now we say when theta is equal to 0, u is equal to the sine of 0, which is 0. And the upper limit, when theta is pi over 2, u is equal to the sine of pi over 2, which is 1. So now we switch everything from thetas to u's, right? Including the boundaries, right? The bounds of the definite integral. So this becomes 0 to 1, u to the 4th minus u to the 6th du. Okay. All right, we're almost done this. You can stick around. Right, okay, so what's that? So what's the antiderivative of u to the 4th? 1/5 u to the 5th minus 1/7 u to the 7th evaluated from a lower boundary of 0 to an upper boundary of 1, okay, which is equal to 1/5 1 to the 5th minus 1/7 1 to the 7th minus 1/5 0 to the 5th minus 1/7 0 to the 7th. Do you need to write that? I mean, you could just write 0. I think it's good to write that just to get in the habit of, so that when it's not a 0, you don't sort of gloss over it and just say, I'm just not used to writing this. And things go bad. So it's 1/5 minus 1/7, which is over 35, 7 minus 5, so it's 2 35ths. All right. Now what? So I think the only thing left is example 3. So now, let's do example 3. Okay, I can wait. How'd that get? I was wondering, is it recording? It's like, how'd that get up there?
All right, we're good.
Okay. Use integrals to determine the area between y equals cos squared theta and y equals sine squared theta on the interval negative pi over 8 to pi over 8. So we need to know, do these functions intersect in that interval? Which one's on top, right? We got to do the top one minus the bottom one, and then plus. And if so, first thing we got to do is just kind of sketch this out. So sketching out. So cos theta looks like, let's just do this. So that's negative pi over 2, and that's pi over 2. So the interval of the integral that we're interested in is simply this. Right? Actually, wait, that cosine doesn't look like that. Cosine. It looks like that. And we're interested in this. So when this part here is squared, it's simply just going to be like that, right? So that's going to be cos squared. Right? That's minus pi over 2, pi over 2. And that's minus pi over 8, pi over 8. Sine theta looks like this and this. So that's pi over 2, that's minus pi over 2. So that's the interval we're interested in. So these guys just, yeah, when we square this, the left-hand side is just going to become positive and be the same as this. Okay, and those values won't be as high as the cosine values are there. So, we're looking at something more along the lines of this. Okay, so this is the sine squared theta. Okay, so it looks like cos squared theta is going to be above sine squared theta in the interval. Okay, so from negative pi over 8 to pi over 8, it's going to look something like this and this. Okay, this guy is the cos squared theta, and this guy is the sine squared theta. All right, so what do we do? So we say we want the definite integral, right? So we're looking for that area, definite integral. From negative pi over 8 to pi over 8 of cos squared theta minus sine squared theta d theta. Okay, what's cos squared minus sine squared? Look at the first page of this section. It's cos squared minus sine squared. Cos 2x, right? Cos 2 theta. It's going to be a heck of a lot easier to do the integral of cos 2 theta than to do cos squared and sine squared, right? Okay, so we need to do what? Well, actually we don't need to do anything fancy, do we? What's the integral of cos 2 theta? I don't need to do any u stuff, right? What's the integral of cos 2 theta? Half sine 2 theta. Right, on the bounds from negative pi over 8 to pi over 8. That's going to be equal to 1/2 sine 2 times pi over 8 minus 1/2 sine of 2 times negative pi over 8. So 1/2 of the sine of pi over 4 minus 1/2 of the sine of negative pi over 4. What's the sine of pi over 4? Root 2 over 2. What's the sine of negative pi over 4? Negative root 2 over 2. So we got root 2 over 4 minus, no, plus root 2 over 4, which is 2 root 2 over 4, or root 2 over 2. Done. Next lesson, next Thursday.